So in this segment, we're going to talk about this funny little statement on page 256 in the e-textbook that just is labeled zero exponent. And it says if a, as long as a is not equal to 0, then a to the 0, or any other number besides 0 to the 0 power, equals 1. That might seem kind of odd to you. Why is that? It's actually a thing that mathematicians created because it made sense. Now, you've already learned the quotient rule, which says if I do a to some power, say the third power, over a to the second power, that's a to the 3 minus 1 power, or I'm sorry, 3 minus 2 power, right? And that's a to the 3 minus 2 is 1 power, or just a. We don't usually write the 1 power, or 1 exponent. So mathematicians ran into the problem of what about a cubed over a cubed? Well, we know that's equal to 1, because anything divided by itself is 1. But if you apply this rule, this quotient rule I just went over, a to the 3 minus 3 is a to the 0. So that shows you that a to the 0 is equal to 1. Right? That statement must be true. It was created because this phenomenon made it necessary to say anything to the 0 power is 1. Obviously, if a is 0, though, we're dividing by 0 in this fraction, and you can't do that. So that's why 0 is not included. So now I want to give you a couple examples of how to deal with the 0 power in different situations. Here's two very similar situations. Okay? The difference is this has parentheses on it, which makes the exponent affect both the negative sign and the 6. But in this one, because the order of operations say do exponents first, and a negative sign is the same thing as multiplying that by negative 1, then we apply the 0 power here to the 6 first, and 6 to the 0 power, according to this rule that we just went over, is 1. So the answer to that, I should put it here, is negative 1. The negative sign stays because it's like multiplying by negative 1, the 6 to the 0 by negative 1, and negative 1 times positive 1 is negative 1. As opposed to this, excuse me, as opposed to this where negative 6 is being raised to the 0 power, and anything to the 0 power is positive 1. So there's a difference there. One is negative, the other is positive. So let's do something a little more complicated, like x plus 5 to the 0 power minus 3. Okay, what would we do with that? Well, x plus 5 is like any other number. As long as x is not negative 5, to make x plus 5 equal to 0, negative 5 plus 5 would equal 0. This x plus 5 is raised to the 0 power is 1. So let's replace it with 1. And now we have 1 minus 3. And what is 1 minus 3? Moving 3 places down the number line from 1 would land on negative 2. And there you have it. There are some examples about the 0 exponent. Thanks.